Hi everybody. In honor of Wacky Tacky Wednesday, I have this beautiful flower motif going on today during your video. So today while I'm gone, I'm still here in video form, and we're going to be going over some acceleration problems and what is acceleration and how can we solve for it. So we're going to go over some notes, do a couple of practice problems together, and then you guys tonight will have that homework motion practice 2 that hopefully you can get done in class if you don't, so you don't have to do it tonight. So it might be a good idea while you're watching the video to write some things down. So if you want to get out your notebook or your iPad, if you're watching the video, confusing, but if you want to get out your notebook and jot some things down, that would be a good idea. So first question of the day is, what is acceleration? What is this big fancy science word that you're telling us, Miss Mosley? What is acceleration? Acceleration is when we change our velocity and the time it takes us to do that. So it's a change in velocity over time. And you can change your velocity a couple different ways. You can change your speed, so speeding up or slowing down changes the velocity. The other way you can change your velocity is changing direction. So if you're going around a corner or you're turning, going straight and you turn left, that's going to change your velocity too, which means if you change direction, you're accelerating. Acceleration can be a positive value or a negative value. If you speed up, you're going to have a positive acceleration. And if you slow down, that number is going to be negative. So if you get a negative answer, sometimes people think, oh, I've got a negative answer, I must be wrong. That's not true with acceleration, because you can speed up or you can slow down. Let's do a couple problems together. Are these things accelerating? Rousing game of are these things accelerating? The first one is if you walk to class at a constant speed. So you're in the hallway and you're walking, pretty steady speed from one classroom to the other. I'm not speeding up, I'm not slowing down, I'm not changing directions, I am not accelerating. Now I'm in a car and I'm driving, and I come to a stop at a stop sign. I go from driving, I slow down and I stop. I'm slowing down, so I'm accelerating. My acceleration will be negative, but I'm still accelerating. And the last one on here is a car that's traveling 50 miles an hour. So you're in the car, you're going 50 miles an hour, and now you're going around a curve. I'm not speeding up, I'm not slowing down, but I'm changing directions. That curve makes me change directions. I am accelerating. If we're going to solve for acceleration, our magic triangle comes back. So we have acceleration on here. Acceleration is equal to the change in velocity divided by the time it takes. So the change in velocity divided by time it takes. And remember, if you have the triangle, you're going to divide and multiply across. This triangle here is a symbol that we see in science, and it comes from the Greek letter delta. So the triangle equals delta, and anytime you see that triangle, it means the change in. So change in velocity, did you speed up, did you slow down? Delta just means what did our velocity change into. Our units for velocity, or for acceleration, I'm sorry, are going to be the units for velocity, meters per second, divided by the units for time, seconds. If I have meters per second divided by second, I get something called meters per second, or meters per second squared. And those are all proper units. Meters per second, meter per second squared. Those are the units that are going to go after my numbers that tell me what the label is. So let's do one of these together. So we're going to practice. And this problem says I'm going to use my 6-step process. I'm going to go through and answer these problems. And the first step is always to read the problem. A driver is traveling east on a dirt road when he spots a pothole ahead. He slows his car from 14 meters per second to 5 meters per second in 6 seconds. What is the car's acceleration? So I want to pick out all my variables, and for acceleration I'm going to have acceleration, time, and my delta v, or my change in velocity. To find my change in velocity, I need to have the final velocity minus initial velocity. So our velocity at the end minus the velocity we started with. So let's look on here. And the first number I see is that he slows his car from 14 meters per second. That's his initial velocity. What did he start with? 14 meters per second. To 5 meters per second. That's his final velocity. In 6 seconds. 6 seconds must be the time it took him to do that. So 6 seconds. What is the car's acceleration? I don't know. I better figure that out. So before I can plug in chug, I need to figure out what delta v is. And to do that, I take the final velocity, 5.5, minus 14 to get my delta v. So I'm going to use my calculator, and I just have my phone calculator, which is fine to use. Well, you can use your iPad calculator, you can't use your phone. So I'm going to take my 5.5 minus 14, and I get negative 8.5 as my delta v. It's okay to be negative, because negative tells me I'm slowing down. I need to turn the pen back on so you can see what I'm doing. Okay, so I have negative 8.5 meters per second is my delta v. Now I can go through and take delta v, negative 8.5, divided by time to get acceleration. And if I take negative 8.5 divided by 6, I get a final answer of negative 1.42 meters per second per second. And that is my final answer. One more. We have a turtle swimming in a straight line towards the shore. He has a velocity of 5.0 seconds. After 4 seconds, its velocity is 0.80 meters per second. What is the turtle's average velocity? So my problem tells me I'm solving for velocity. It takes the turtle 4 seconds. He started at 0.50 meters per second. He ended at 0.80 meters per second. Now I can solve. I'm going to take 0.80 minus 0.50, plug it into my calculator so that I make sure I get a right answer. 0.8 minus 0.5 is 0.3, obviously. 0.3 meters per second is my delta v. And I want to find acceleration, so I'm going to divide these two. 0.3 meters per second divided by 4 seconds gives me an answer of 0.075 meters per second as my turtle's acceleration. The turtle is speeding up, so he has a positive acceleration. Okay. You went through a couple problems. If you need to go back and do those, go right ahead. But this is the worksheet that you have, motion practice 2. It is 6 questions for you to do either right now in class or tonight at home. Have this ready to go on Thursday so we can talk about it and go over it and make sure that we did it correctly. Any questions, come see me in the morning or after school to get some help. Okay, have a good day. Bye.